Hi, Miss Neville Science students. Here's our recorded lesson about generators. We learned about electromagnets, and we were able to see that through electromagnets, we see a happy marriage between electricity and magnets. How, when the two of those work together, it creates a stronger magnet. Yes, it makes the magnetic field go from being very small, where it only attracts things very close to a magnet, to very big, a much stronger magnet. Today, we're going to keep thinking about electricity and magnetism as we push our minds further in learning about generators. Our learning objective today, please write generators in your notes. You do not have to write what's in green. I will construct a response that explains how generators are built and function as a power source. That's going to be your question that you're going to answer in your notes today and on Schoology after you've watched this recorded lesson. So it's important for us to know, please write this down. You do not have to draw this picture. The question is, what is a generator? A generator uses electricity and magnetism to become a power source for anything. Yes, a generator, as some of you wrote in some of your past Schoology assignments, is a power source. Instead of using a battery, I could use a generator to power a load. We see this GIF here and how a generator works. We see that the parts of the generator, which we'll talk more about in a second, the parts of the generator include an iron core that's wrapped in a conductor or copper wire. We see it still has a load, and it has two large magnets that stay by themselves. They stay stationary. They don't move as that iron core and copper wire rotate between them. But what causes the iron core to spin? Remember to pause this page if Ms. Neville's going too fast. Turbines. Yes, turbines, you'll want to write down what you see here in green and white. You'll want to write the words down that you see in green and white. A turbine is a scientific word for fan. Yes, a turbine are spinning blades that are pushed by us. We can turn it, wind, or water. Yes, that turbine is hooked onto the end of an iron core, and as that turbine spins, it causes the iron core wrapped in copper wire to spin as well. So please write this down, and you will be drawing this picture. What are the essential components of a generator? What are the essential components of a generator? We should know that a generator has two pretty large magnets on either side of it. Okay? We're going to see that there's an iron core here. That's that black rod that's wrapped in copper wire. At the end over here is going to be the turbine or fan hooked up. That's what's going to cause that iron core to spin. They're connected. And then on the other end of our iron core is our load. Our two magnets, our iron core wrapped in copper wire, our conductor and magnet, and our turbine, our fan, would be hooked on over here. In your picture, it may be nice for you to draw a fan, the blades of a fan, over here on this side of the iron core. And our load, which could be anything that's powered by a circuit, our load is going to be on the other side here. So please write these notes down. How does a generator function? How does it work? There's 3 steps that you need to make sure you understand. Remember, a generator is a power source. So the blades blades of the turbine, that fan, remember that fan is connected to my iron core that's wrapped in copper wire. The blades of the turbine begin to spin. As they begin to spin, a copper wire that's wrapped around that iron core, it will begin to spin as well. The two magnets, and it's going to spin between those two magnets that surround it. Remember those big magnets on the outside of it. As that copper wire spins between those two magnets, we're going to find this is where the magic happens. Yes, this is where electricity is produced. Step 3, the copper wire carries the electrical energy to power the load. Yeah, so as that copper wire, which is a conductor, remember the conductor's job is to carry energy. It's going to carry the energy that it's made from that spinning between the two magnets. It's going to carry that electrical energy through it to power a load. So it could be any kind of load. Remember, we looked at the picture here. As that copper wire wrapped in an iron core, or the iron core wrapped in copper wire began to spin between these two magnets, it began to power the load. So this is how a generator is a power source. We want to make sure we know this, guys. A generator does not need a power source. A generator is a power source. Please pause this screen if you need these notes. So, where do we find generators in the real world? Some of you have possibly been camping or glamping, where you glamorously camped using electricity, and you may have used something smaller, like a small generator. Maybe for a power outage in your home, you've had to use a generator. You do not have to write these notes down. Or you could have seen, and I'd never seen one before until I began teaching about generators. Hospitals, when they have power outages, they have huge generators. Yes, this generator is as large, if not larger than my classroom. So generators can be really small to power small loads, like a house or a camping RV. Or they could be huge to power large loads like a hospital.